Okay, so now have a look at surds. When you're working with surds, if you can break them down into squared numbers, it makes things a lot simpler. Like root 12 breaks down into a root 4 and a root 3. Root 4 is 2, so that can be written as 2 root 3. Root 48 can be written as a 4 and a 12. Root 4 is 2, 3 2s are 6. 12 can be broken down again into a 4 and a 3. Root 4 is 2, so you get 6 times 2 is 12, root 3. 75 can be written as a 3 and a 25. Root 25 is 5 and then a root 3. So you've got 2 root 3's, add 12 root 3's, add 5 root 3's, which gives you 19 root 3's. So breaking them down makes life a lot easier. Surds, rationalized denominator. There are two types. The one is when there's one term in the bottom, like this 1 over root 3. What you do then is you multiply each side by the bottom. So that's 1 times root 3 over 3 root 3, which is root 9, which is an ordinary 3. And the second type is when you've got two terms in the bottom, like this one here, root 3 minus root 2. And what you do is you multiply the top and bottom by root 3 plus root 2. So that becomes 3 root 3 at 3 root 2. The bottom becomes root 9, which is an ordinary 3. Root 6 minus root 6, which cancels off, minus 2. So the top line becomes 3 root 3 at 3 root 2. 3 take away 2 gives you 1. The surds cancel off as they should do in the bottom, giving you 3 root 3 plus 3 root 2. Okay, the next one I want to look at, you just check the bottom is root 3 minus root 2. So I'm going to multiply top and bottom by root 3 plus root 2. Because there's more than one term in the top, I would put brackets around it. So the top becomes root 6 plus root 4, which is 2, minus root 9, which is minus 3, minus root 6, and the bottom becomes 3 minus 2. You can leave out the root 6's because they always cancel off in the bottom line. Root 6 minus root 6 is gone. 2 take away 3 is minus 1 over 1, which is just minus 1. I've got factorising in here, but we know this quite well at this stage. Common numbers, common letters, difference to squares, easy quadratics, hard quadratics. If you look at this one here, x5 minus x3, I can take an x3 out, leaving me with x squared minus 1. Don't forget that's a difference of two squares, so that becomes x3, x minus 1x plus 1. These ones here, the negative quadratics, I always think are a little harder to factorise than the others. So I would pull that minus sign out and change all the signs. X squared plus 5x minus 6. Then just keep that minus sign sitting outside. What multiplies to give minus 6 and adds to give 5? It's a 6 and a minus 1. First exam question we'll look at is from June 2013, and it's quite simply rationalising the denominator of that fraction there. Bracket everything, multiply it by 1 plus 2 root 3 over 1 plus 2 root 3. Multiply out the top, 5, add 10 root 3 plus root 3, and then that becomes root 9, which is 3. 3 times 2 gives you 6. Bottom line, 1. And I wouldn't worry about doing those two and those two because you always cancel off. Just working with these two. Root 3 times root 3 is root 9, which is 3. 3 times 4 is 12, so it becomes minus 12. That tidies up. 5 plus 6 is 11. 10 root 3 plus 1 root 3 is 11 root 3 over minus 11. Now you would be expected to divide through by minus 11. 11 divided by minus 11 is minus 1. 11 divided by minus 11 is minus 1. Root 3. 2012, question 4a was a really straightforward one. You just multiply top and bottom by 3 plus root 2. Top line becomes 3 times 14. 3 4s are 12, put down your 2, carry a 1. 3 1s is 3, add the 1 you're carrying, 4. Plus 14 root 2. Bottom line becomes 9 minus 2, which is 7. So that becomes 42 plus 14 root 2 over 7. And you would be expected to divide through by your 7 at the end. June 2011, question 3b. It was a mixture of fractions and surds in this one. Now, when you're adding fractions, the bottom needs to be the same. So we'll need to make both of those bottoms the same. 3 minus root 5, 3 plus root 5 will be the bottom line of each of the fractions. To change this bottom into this, we need this extra term on top. Because there's more than one term on top, put brackets round it. So it's 3 add root 5. On this side the extra is 3 minus root 5. So put that on top. Once the bottoms are the same, you can add the tops. So we'll multiply them out and add them together at the same time. 6 add 2 root 5, add 3 root 5, add 5, plus 15 minus 5 root 5. All over the bottom line, 3 minus root 5, 3 plus root 5. So tidying this up, 6 add 5 is 11, 11 add 15 is 26. 2 root 5 add 3 root 5 is 5 root 5, take away 5 root 5 has gone. Over the bottom line, 9, 3 root 5 minus 3 root 5 disappears as it should do, minus 5. So it gives you 26 over 4, which is the same as 13 over 2, which is 6.5. The first exam question we're going to start off with is from June 2013. It's question 5a. And you are told to write this equation in the form of x plus a squared add b. That's just completing the square. It does start with x squared, so we're fine, we don't do any more there. Half the middle term, take the new term away squared and drop down the m term. So that becomes x plus 3 squared add 8. Part 2 of that equation is talking about the turning point. There's only 3 marks for that. Now, I would be inclined to sketch the graph. There's your x squared graph. X squared plus 3 is moving it back 3. So there's x plus 3 squared. And then lift it up 8. So minus 3, 8 will be my turning point. So turning point is minus 3, 8. The next part of this question is talking about values of x for which y is increasing. So increasing functions is onto differentiation. So we'll leave that until we're doing differentiation.